Guys, welcome back. In my previous video, we talked about how to multiply two complex numbers which are provided to us in the polar form. In this video, I want to talk about what happens when we divide these complex numbers. Okay, guys, it's not too complicated. All we have to see is we have to go through some steps and then we will be able to get a nice formula for this. For the product or for multiplying two complex numbers in the trig form, what we saw or what we realized that we have to multiply the absolute values and then we have to basically add the angles. If we had a cosine of theta 1 and theta, sine theta 1, and then the other one was theta 2, cosine theta 2 and sine theta 2, then the product was cosine of theta 1 plus theta 2, and same thing with the sine of theta 1 plus theta 2. So we added. Now when we are dividing, obviously we already know that the division and multiplication are like the inverse processes. So one can already figure out if multiplying two complex numbers, we got to add the angles. What would one do if we are dividing? Guys, you can already, probably you guys already guessed this, but let us kind of go over some steps and see what we actually get. Okay, so we already have those complex numbers. So let me take the quotient of z1 over z2. So obviously it's going to be r1 over r2. We have to divide those absolute values, nothing really crazy about it. And then the rest we have to write it, cosine theta 1 plus I sine theta 1. And then times, in the denominator, I have cosine theta 2 plus I sine theta 2. So I'm going to write cosine theta 2 plus I sine theta 2. Guys, we cannot just simplify this by just looking at it or by just using there's no other easier way of simplifying it. So what one has to do sometimes is when we are dividing complex numbers, we have to multiply by the complex conjugates. And if you have already worked on complex numbers, you already know to actually simplify complex numbers, which are all provided in the standard form, and you're trying to divide or take the quotient, you have to multiply by the conjugate, right? Complex conjugate. And in this case, the complex conjugate would be the denominator, but instead of a plus, we have to change it to a minus. So that's exactly what we're going to do here. We're going to multiply upstairs and downstairs by the complex conjugate of the denominator. Guys, keep in mind, it is most of the times, or I would say all the time, it is the multiplying by the conjugate or complex conjugate of the denominator, because that is what helps to simplify things. Okay, and we want to simplify this. We want to have it in a form where we can see the real part and an imaginary part, because like this we cannot see the real. It is not divided into real and the imaginary part. So we want to simplify so that we can see the real and the imaginary part. Okay, so multiplying by the complex conjugate, cosine theta 2 minus I sine theta 2 upstairs as well as downstairs, cosine theta 2 minus I sine theta 2. Guys, once we simplify all this, and I think I'm going to skip some steps here, I don't have so much room here. What's going to happen, guys, this is what's going to happen, and I would like you to actually go over this and multiply out everything and see if that is what exactly you get what I'm going to write here. Guys, in the denominator, finally I get something like this, cosine square theta 2 plus sine square theta 2 when I simplify. And we already know that the cosine square theta plus sine square theta is always going to be equal to 1. That is one of the first basic Pythagorean identity for the trig functions. So that means the denominator, I'm going to just get that 1, which is a good thing, because we wanted to somehow get rid of the denominator, or at least get rid of the I in the denominator. In this case, the denominator simplified to a very simple number 1, which we don't even have to write. And then, guys, when I distribute all this upstairs and I simplify things, we rearrange like we did when we multiply, finally this is what we get. We get cosine of theta 1 minus theta 2, and then plus I times sine of theta 1 minus theta 2. Guys, this is exactly what we get. So finally, what we can say is, in the denominator, there is just 1. So I can already get rid of this. We don't have to write that information. So finally, when we take the quotient, when we divide two complex numbers, then what happens here? You divide their respective absolute values, r1 over r2. And what do we do with the angles? You just subtract theta 1 minus theta 2. So guys, when we multiply, you add the angles. When we divide, you just subtract the angles. So that's how people like to remember these things. Guys, this is how we divide. We already looked at how to multiply two complex numbers. In my next video, I'm going to talk about, actually I'm going to take up some examples and we're going to look at some of these examples. Okay, till then, guys, take care. I will see you next time.